Hi, everyone. My name is Anubhav Gupta. I work as product manager at Arista Networks. My topic today is what makes our AP consume so much power. So with every Wi-Fi standards, we have seen that AP power consumption is increasing, right? We started with 2.4, then we added 5 gigahertz radio, then we added 6 gigahertz radio, then 2x2, 4x4, 8x8, 12x12, 16x16, that's where we are going. And then we started adding more BLE, Zigbee, temperature sensors, and hence the power consumption of the AP is increasing continuously. So what is the goal? The goal is to reduce the AP power consumption, and the purpose of this presentation is to understand the key knobs which will help us in achieving this goal. So for that, we started a study where we found the components which are the power guzzlers into an access point, right? Hardware components like CPU, a cryptography engine, and Ethernet link speed are the most which are consuming the power. And from the radio components is the number of radios, the number of radio chains, and the power amplifier which consumes the most of the power. But it is not easy to tweak all of them, right? And that's where our experiment went into, and figuring out what are the key parameters which can be controlled dynamically to save the power into an access point. And this came up with these 4 components, which is the number of radios, Ethernet link speed, the number of radio chains, and the transmit power. So with that, we started an experiment to understand that how we can tweak each component and what is the benefit of each component, right? Like for radios, we turned off all the radios and saw what was the power consumption of the AP. And incrementally, we started turning on each radio one by one. Then 2. 2 is a combination of any radio, right? And then all the radios. And you can clearly see, if you turn off even a single radio, there is a saving of 0.5 watt and maximum up to 1.3 watts. Similarly, we did the experiment for the Ethernet link state. And this is interesting. If you see, the power consumption for 1G and 2.5G was same, right? As David mentioned, right? 5 Gbps is something which you will never consume. Is it required? But somebody may argue, yeah, that is required. But let the system decide and negotiate it dynamically. And that's where you can easily save 0.6 watt of power when you negotiate the link speed as well. And this was another experiment which was very interesting, the radio chains, right? Where you can clearly see that the combination of the number of radios and the right amount of chains, if you turn off bring down the AP from 4x4 to 2x2, you can save good amount of power. And bringing down it from 4x4 to 1x1, you can almost save 1 watts of power, right? And last but not the least, we did the experiment with TX power, which is known to everybody, right? It does not only saves us from the interference, reducing the TX power, but it also saved the amount of power that AP is consuming. So bringing down the radio or the amplifier from 24 dBm to 12 dBm saved almost 1 watt of power. And even if an administrator does not want to shut down the radio, they can reduce the power to save the TX power to reduce the power. So taking all these experiments and this data, we knew what were the knobs and how much benefit they're going to give us, right? And that's where we fed this data into our DPO, Dynamic Power Optimization Algorithm, right? So using the dedicated scan radio, the data regarding these parameters is fed into a DPO, like client capability, the load onto the system, right? The characteristics of the client. All those are fed into DPO, and DPO takes any one or combination of these decisions, like turning off the radio, renegotiating the link speed, and turning off the radio chain, reducing the TX power, right? And at the end, our experiment showed that we can save 2.4 watt average power per AP per hour. So does this ring any bell? Is there any economic value of this saving? It's 2.4 watt per hour per AP. I don't think there's an economic value, that much economic value of this saving from a big organization perspective, right? So what is the bigger picture to this? The bigger picture is this. It has a huge environmental saving. So we went ahead and analyzed the environmental benefit of this saving. The amount of power, the average power we are saving, right? If you extrapolate that by 1,000 APs deployed by an organization for a year, then this saving is equals to 10,000 kilograms of CO2, carbon footprint. And that is equal to planting 400 trees to basically absorb this much of carbon dioxide. So that's the impact of this saving. And that's what we want as a community, as a Wi-Fi community, to go ahead and start putting efforts towards the sustainability of the access point as well. With that note, I will end my talk. Thank you very much.